Hello, my dear student. Welcome to Exam Prep Tool. If you are preparing for GATE CSE or GATE DA, this is the correct place. 300 questions, 300 quality questions I am going to explain here. Mostly in GATE examinations, questions will come from these 300 questions only. Most of my students every year used to say this only to me. Sir, questions came from your notes. So I'm strongly saying to you, don't miss one question also out of these 300. It will really helpful to you in the examination. You will get a lot of advantage. First of all, myself, I am Subbarao Lingam Gunta. My students used to call me Reddy sir. I have 14 years of teaching experience. I guided more than 25 lakh students. Right? And one more thing I want to say to you, I am from IIT Bombay, right? In computer science department. I am the GATE top ranker. All my team members are IITians. 300 quality questions we made. Don't miss one also. Definitely most of the things will come in the GATE examination. And while seeing this lecture at anywhere, if you find out any doubt, this is our WhatsApp number, right? Message us. This is our WhatsApp number. Please message us, right? Your doubt will be resolved by our team members. Hope this class will be really useful to you. Go ahead. Question number 16, what is the answer? Start doing. I think same, right? So everyone know this is the mask. Everyone know this is the mask. 12 bits for mask. 14 bits for mask. 16 bits for mask. 15 bits for mask. This is the net ID. This is the net ID. This is the net ID. This is the IP which is coming. Packet is coming with this destination address. Packet is coming with this destination address. Yeah, let me try one time. 131, 23, 151, 76. According to first one, how many bits for? According to first one, how many bits for mask? 12 bits. So 255, 12 bits. I think 4, right? 4 ones are there. 4 ones is I think 240. 240. Remaining zeros. It is going to be 131, 23, 23. I think 16th bit it will satisfy. Remaining things are zeros. So is it satisfying network ID? Net ID satisfying 131.16. Yeah, I think it is satisfied. Please verify if I done anything wrong. 12 bits only. 8 plus 4. 4 bits means 240. In the 240, 2 power, I think 2 power 4 also there, 16. 23 also 16, I think 16. So I think first one is matching. What about second one? Let's check. What about second one? 14 bits. 131, 23.151.76. Right? So this is the 14. 14 means 255 here. 14 means 255 here. 255, no. 14 means what? 8 plus 6. I think it is a 252. Dot 0 dot 0. 131.23. What is the 23 binary number? 16 plus 4 plus 3. 3 means 11. 0, 1, 2. 0, 1, 2, 3, 4. 16 plus 7, 23. Right? I think last 2 bits you leave remaining. 1, 0, 1. Remaining 1, 0, 1. So remaining what? 8 bits. So I think it's going to be 0, 1, 2, 3, 4. 16 plus 4, 20. Dot 0 dot this. check properly if I done. So second one fail, not matching. Second one fail, not matching. What about third one? 131, just doing end operation, right? Do properly without doing mistake. 151.76. Third one is 16 bits. 255, 0.0, 16. It will become 131.23.0.0. I think this also match, not fail. Let's go to fourth one. 131.23.151.76. Right? So mask is 15 bits. 255.254.0.0. It is a 131 dot. In the 23, last bit is 1 is there. Last bit 1 is there, remaining as it is. Last bit is there, remaining as it is. I think 22.0.0. I think this also matching. So first one is matching, last one also matching. I think everyone know first one matching, last one matching means, right, wherever more ones are there, that will be the answer. More ones are there, that will be the answer. More ones means less host. More ones means less host. I think answer is output interface is 1. What is saying? The identified output interface on which this packet will be forwarded is, I think 1. A is the answer. See, same problem asking different ways. Same problem asking in the different ways. Same problem asking in the different way. Yesterday 15 problems, almost like half problems are this model only. But it is going to be classless inter-domain routing. No class here. Divide /12 means 12 bits in the mask. /14 bits in the mask. /16 bits in the mask. /15 bits in the mask. Mask 15 bits means 15 ones. Mask 16 bits means 16 ones. So like that, right? I think this is going to be first option. It is the 2, it is the 3, it is the 4. 1, this is 4, I think. This may be 2, this is 3. So 2, 3 fail, 1, 4 pass. But the one which contain more ones is fourth one. Fourth one means interface 1. Fourth one means interface 1. Careful. Interface 1. Careful. Answer is A. Someone is saying longest one I will take. Longest one is 16. Longest one 16. Then you will be wrong. Longest one is 16, then you will be wrong. No, every year will come. That's what I am saying. Right? Yesterday 8 problems, almost half of the problems are these only. Today some other way it came. Today some other way. It is the CIDR notation. This is the CIDR notation. Right? Many questions came. These all are PYQs only. Small changes may be there. Whichever I feel really nice problem, I am covering. Whichever I felt really nice problems, I am covering. If many are matching, longest matching. Remember, you should know the notation. CIDR notation you should know. /15 means 15 bits per mask. Means in the mask 15 ones. So how many hosts are there? 32 minus 15, 17. 2 power 17 hosts are there. If the mask is 16, right? 32 minus 16, 16 bits per host, 2 power 16. So like that. Okay, question number 16 we done. Let's go for question number 70. Question number 70. For 12 subjects of GATE examination, every subject is approximately 200 questions to 300 questions. 300 quality questions were designed. 12 subjects, every subject 200 to 300 quality questions were designed. Approximately 2400 questions to 3600 questions. These many quality questions were designed with video solutions. Mostly in GATE examination, all questions will come from these only. 12 subjects, every subject 200 to 300 questions. Our team is all IIT experts. Myself, as I mentioned to you, 14 years. Most of my students are there in IIT. Most of my students are there in MNCs, big MNCs. Most of my students are top 100 rankers, top 10 rankers, top 50 rankers. If you solve all these questions, I'm very sure, I'm very sure your rank will improve by at least 10 times. Through experience, I'm saying mostly questions will come from these questions only. Don't miss at any cost. So for if you want to subscribe for this course name is called as Rank Improvement Course. Rank Improvement Course for CS, Rank Improvement Course for DA. For admissions, you can WhatsApp me to this particular number, or you can directly go to exampreptool.com. Exampreptool.com. You can subscribe from there also. It is really useful to you. Don't miss at any cost. This is Utilize the last 2 months quality time in the quality way. I hope you will get a lot of benefit from this. All the best. Go to question number 17. The address resolution protocol ARP. Listen, ARP 3 letters. MAC also 3 letters. ARP 3 letters. MAC also 3 letters. The purpose of ARP is finding MAC address. ARP 3 letters. MAC also 3 letters. Purpose of ARP is finding MAC address. Finding MAC address that corresponding to IP address D. Everyone know this. Go to question number 18. In a network of LANs connected by bridges, packets are sent from one LAN to another through intermediate bridges. Since more than one path may exist between two LANs, packets may have to go routed through multiple bridges. Why is the spanning tree algorithm used for bridge routing? Fine. Go ahead. What is the answer of this? So everyone know in the spanning tree, because it is a tree. In the spanning tree, there is no cycle. In the spanning tree, no concept of cycle. So avoiding loops in routing paths. Fine. That's okay. Can you go ahead? So purpose of spanning tree is avoiding loops. Because this spanning tree never have cycle. Cycle not there means there is no chance of infinite loop. Avoiding loops. Spanning tree purpose is not shortest path. Shortest path purpose, there are routing algorithms. Shortest path purpose, there are routing algorithm, Dijkstra's algorithm there, and Bellman-Ford algorithm there, So shortest, spanning tree is there to avoid loops. Shortest path purpose, Dijkstra's is there, Bellman-Ford is there. Yeah, fine. Go to question number 19. Yeah, what is the answer of this? This is used for TTL in IPv4. Yeah, perfect. Aman is saying what? What is your doubt? Everywhere you written yes, yes, yes. Where is the doubt? Gootle. Everywhere is saying yes, 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 and my doubt. Where is the doubt? If we replace bridges by routers, then go there. Since more than the path may exist, two LANs packets may be routed through different bridges. That's, I think it is not a big deal. So the thing is, here the question is spanning tree. Right? It doesn't matter. Here the question is spanning tree. Yeah, go to the next one. Question number 19. Diksha is saying, sir, what reverse lookup in application layer? So if you, Diksha, if you have any problem, please send to me. Right? I will do, if I know answer, right, I will say directly. If I don't know, I will do some work and I will do that. Right? I don't want to take trial on this, because some classes I done the trial. Unnecessarily class will be wasted. Half an hour will be wasted. Right? You send to me first. I will do some work. I will say. I cannot say randomly something. If I say randomly something, some time will be wasted. Now can you go to question number 19? A host is connected to a department network which is part of a university network. A host is connected to a department network which is part of the university network. It is a host. A host is connected to a department network. So CSE branch, which is part of university network. It is the university network which having maybe CSE, maybe mechanical, maybe ECE, maybe civil branch, maybe chemical branch. It is the CS, it is the mechanical, it is the electrical or electronic, something like this. It is the university, right? So university network. The university network is in turn is a part of the internet, right? So this is the one university. So internally contains so lot of things. Some other university. So this total is network. It is some university 1, it is university 2, university 3. So like that. Total network. The largest network in which Ethernet address of the host is unique. Oh, Mrs. branch with most of the girls. Which branch? Most of the girls are there in CS. Arey Shreyas, most of the girls are there in the CS. Oh, you want to say electronics. And communication. Most of the girls are there in the electronics and communication. What kind of gate preparation it is? Arey Shreyas, what kind of gate preparation it is? Is it part of gate syllabus? Arey, where is Rohit? Where is Rohit, yaar? Where is Rohit? Which MTech branch has more girls? Arey, Bobby, why don't you marry dog? Arey, Bobby, why don't you marry dog? Marry dog, na? Just marry dog. Bobby, just marry dogs, na? Anyhow, what is the answer for this? What is the answer for this? See, everyone, this may be people will do mistake. This question people may be do mistake. Remember everyone, the largest network in which the Ethernet address of the host is unique. This is the host. Host having the MAC address. This MAC address is unique. Everyone listen. This MAC address is unique within the LAN. This MAC address is unique within the department or within the university or within the network. What is the answer? Remember, IP address and MAC address. Both are unique in the entire network. He is talking about MAC only here. MAC address is unique in the entire internet. The only thing is MAC is related to hardware level. Every time comparing with the hardware level, every time doing operation with the hardware level, it is going to be slow. Right? You no need to do operation, right? With going to hardware level and doing that, it will unnecessarily waste lot of time. MAC address also unique, right? All over the internet. The only thing is it is the larger size and doing operation with that, right? Some time will be wasted. Hardware level doing operations, and the MAC address is little bit bigger also, right? Lot of time will waste. So comparing IP, comparing the MAC, comparing IP easy. So that is the reason they selected for, right, IP address. For communication, right, from one place to another place, normally we select IP because comparison easy and size also easy, less calculations and so on. Remember everyone, MAC is unique all over the internet. Yeah, so maybe one computer having two MACs. One computer may be having two NICs, but MAC address is unique all over the world. One computer may have multiple MAC addresses. One computer may have multiple NICs, but MAC is unique all over the world. Right? Careful. Fine. Concentrate. See, coming at 10:45 and playing jokes, there is no meaning. Everyone is sleeping. We came here, so we should do good work. One or two jokes, okay. Arey Ahan, I will block you. Ahan Bhaiya, I will block you. Ahan Bhaiya, I will block you. Remember. Right, go to the next problem. Question number 19, answer is, right, MAC address is unique, right? Total internet, MAC address is unique. Right, fine. Question number 19, if anyone don't know, please take care of this. IP address is unique, everyone know. IP address is unique all over the internet. MAC address also unique all over the internet. Then why you are not comparing with the MAC? Right, the reason is it's a costly, it is a time consuming, it is a hardware level. So there are so many reasons. In the similar way, your phone number, your phone also having internally some number, but we will compare only with the phone number. The reason is it is easy. If you go inside the machine, every machine is having one machine number. Right, fine. Next one, TCP unique sequence number is assigned to, not to each segment, right, to each byte. Right, TCP, a unique sequence number is assigned to each byte. TCP is byte addressable. TCP is byte addressable. Right? Careful. Everyone know this also. Sir, what is the answer for this? For what? Please concentrate on the class. Concentrate on the class. Saurabh is saying, sir, say go to hell, sir. I will block you, Saurabh. Saurabh, I will block you. Then indirect meaning is go to hell. Saurabh, one time block, right? Then it is called go to hell. Then it is called go to hell. Yeah, go to the next one. Go to the next one. Array, it is a sleeping time. It is a sleeping time. How can you play jokes? Can you go to question number 21? What is the answer? By what question? That is illegal, sir. One computer having one NIC card. Maybe that is illegal, right? But they bought two NIC cards. Depending upon requirement, they will use. See, some people bought 2 SIM cards. Some people bought 3 SIM cards. Right, fine. Can you say what about question number 21? Question number 21. Class B network. So 16 network, 16 host. Subnetted. Subnetting also done on this. Okay, fine. And a broadcasting address is this. Remember, it is a broadcasting address. Remember, it is a broadcasting address. Then he is asking what is the subnet mask. So what I will do is, first of all, to this one, let me convert into binary format. 144.16.95 is 010 5 ones followed by all ones. Okay, fine. Now the problem here is, it is a DBA address. The problem with this one is it is the DBA address. DBA address means host party is all ones. DBA means host party is all ones. DBA means host part all ones. But the problem here is, until which part is host? Is it the only host part? Is it the only host part, or is it host part? Or is it host part? I don't know. When you say DBA, host part is all ones. Until which part is host, I don't know. Host is until here, host is until here, host is until here. We really don't know. This is the problem. Right, fine. Now let's see the first option. 255. What is the 224? I think 111, 0, all zeros. Yeah, according to, everyone listen. According to 224 followed by zeros. Yeah, according to the option A, 8 plus 5, 13 bits are, according to option A, 13 bits are host part. According to option A, 13 bits are host part. If 13 bits are host part, because of given one is a DBA, host part all ones. What I mean, 13 ones should be there. Is it 13 ones continuously? 8 plus 5. Correct. According to option A, in the DBA, from the right hand side, 13 people should be ones. 13 people should be ones according to option A. Yes, in the DBA, 13 people once already there. So 13 people are host according to option A. According to option B, 240 means 4 people. 4 zeros. and here 8 more zeros. According to option B, 4 plus 8, 12 people. 12 people are host. If 12 people are host in the DBA, 12 ones should be there. Yes, that is also correct. So B also correct. According to option C, according to option C, according to option C, according to option C, 8 plus 3, 11. So 11 bits for host. If 11 bits are host to, right, 11 ones should be there in the DBA. That is also correct. So could be any one of, right, A, B, C. Answer is, I think D is the answer. Answer is D is the answer. The problem here is, listen, the problem here is we don't know until which part, we don't know until which part host. Actual host is 16. You done the subnetting. So host part will decrease. So answer is host part will be either 15 or 14 or 13 or 12. I don't know. How many bits are host? We don't know. If 13 bits are host in the DBA, last 13 people are ones. Yeah, it is satisfied. If the 12 people are host in the DBA, last 12 people are ones. That is also satisfied. If host is 11 bits, then in the DBA, last 11 people are ones. That is also right. All satisfied. The problem here is host is how much? Host is how much? So actually host purpose 16, after subnetting, it may be 15, it may be 14, it may be 13, it may be 12, we don't know. Because of that reason, all are satisfied. But subnetting will be from the first 3 bits now. See, what is the meaning of DBA? DBA means host part all ones. DBA means host part all ones. So let's see this. Let's see this. Let's see this one. DBA. 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 Class B. Class B. 16 network. 16 host. This host is again divided into subnet and host. Right? Suppose 16 maybe, let us assume that 313 in the DBA 13 ones. In the DBA 13 ones. Suppose the 16 412. 412 subnet is this, host is this, DBA 12 ones. Arey Bhavi, you got or not? Bhavi saying 8 subnets. We don't know, na? He never mentioned in the problem how many bits for subnet. He never mentioned in the problem how many bits for subnet. He never mentioned in the problem how many bits for host. He never mentioned. Chalo. I think everyone got. So this problem is interesting. Please take care. You may get in the exam. Please take care. Because something interesting is there. I kept 20 stars. Please go through it one time. Please go through it one time. Go to question number 22. An organization has a class B network. He didn't mention subnet how many. He didn't mention host how many. Because of class B, I can say 16 plus 16. Subnetting is done. Oh, host part is decreased. How much decreased? I don't know. Go to the question number 22. An organization has a class B network and wishes to form subnets for the 64 departments. So remember class B network. Let's see, class B, 16 network, 16 host. Subnetting is done. 64 departments, see, and wishes to form subnets for 64 departments. An organization have class B network and wishes to form subnets for 64 departments. I think 2 power 6. 6 bits. It may be 10 bits. 2 power 10. Then he is asking, right? Then he is asking the subnet mask would be. So I think subnet mask means what? Listen, mask means network part, subnet part once. Host part, zeros. So this 16 plus 6 ones. Host part zeros. 22 ones. 255, 252. 16 plus 6, 22. Lastly zeros. D. Mask means corona. Shashank is saying mask means corona. Arey dog. Arey Shashank dog. Arey Shashank dog. One dog is barking background because one more dog is here. That dog partner is here. That partner name is Shashank. One dog is barking outside because one more dog is in my class. One more dog is there in my class. Chalo, next problem. I think this is also nice one. Please take care. I am repeating once again. Class B, 16. Next one, subnetting is done. 64 departments purpose subnetting. So to indicate the department number, one number required, so one binary number required, so 2 power 6 bits for subnet. So mask means network part plus subnet part once. So 16 plus 6, so 22 ones are the remaining zeros, that is a mask. So D is the answer. Go to question number 23. Question number 23. Yeah, it is a nice problem. Can you go through this also? This is a nice problem. Can you go through this also? Arey Aman dog, concentrate on the problem. Aman dog, concentrate on the problem. Don't concentrate outside dog. You are a dog, you concentrate on yourself. Can you try this one? It is a nice problem. A host X has IP address and is connected through two routers R1, R2 to another host Y with IP address something. Router R1 having IP address. Router R2 has also having IP address. The net mask used in the network is 255, 255, 255. Given the information above, how many distinct subnets are guaranteed to already exist in the network? Yeah, so let's see. It is an interesting problem. Can you see this one? It is an interesting problem. It is a one IP. It is a one more IP. One more IP. One more IP. One more IP. One more. Can you help me now? Totally how many IPs? How many IPs can you count? How many IPs can you count? How many IPs can you count? This is a subnet mask. It is a mask. It is a mask. How many IPs can you count? 1, 2, 3, 4, 5, 6. 6 IPs are there. 6 IPs. Now listen. First IP, second IP, third IP, fourth IP, fifth IP, sixth IP. Now, can you help me now? First IP and mask. Can you do end operation? One and mask, end operation. What is the answer? One and mask. What is the end operation? First IP and mask, end operation. What is the answer? 255s are there, means same will come. Last octet only different. 224, 111, 97. 97 means 64, 32. I think 64, 32, 96. I think it is a 96. Check properly. Next one. Can you help me now? What about 2 and mask? 2 and mask. 80 and 224. 80 and 224. 64. 3 and mask. 3 and mask. 135, 224. 224 contain 111. 135 contain 128. 128. I think only 128. 4 and mask. 4 and mask. 110 and 224. 96. 5 and mask. 5 and mask. 67, 224. 64. 6 and mask. 155, 224. 128 there. Plus 32. 192. What about 224 and 155? This can be written as 128. 128 plus 64 I cannot write. It's become 192. No, I cannot write. 32 can I write? No, it will become 60. So I think it is going to be 128 only. So if you see the different, 64 there, 96 there, 128 there, 64 repeating, 96 repeating, 128 repeating, 64, 96, 128. Answer is B. Answer is B. Answer is B. 64, 96, 128. These are the only different. Every one, if you do AND operation, you will get network ID. 3 networks only there. So 3. 3 networks only there. So 3. 3 networks only there. So 3. Right, fine, perfect. Simply do AND operation, nothing there. Question number 23. Question number 23. Just to do AND operation. Just to do AND operation, you will get to know, because mask is given. If mask not given, I could have done some other way. Mask given. Just to do AND operation, how many IP, how many networks are there, you will get to know. IP and mask, AND operation, network ID. So I think 3 different networks IDs are. Someone is saying that Class C network and subnet mask having 28 bits. See, from the above information only, he is not asking how many distinct subnets are guaranteed to already exist in the network. See, some networks you may not use. Are you getting? Some networks you may not use. With the given information, how many networks guaranteed? Right? So, yeah, whatever you said, that is correct. Right? It is not necessary every subnet you will use. It is not necessary every subnet you will use. Yesterday we done. See, yesterday we done. Totally you have 2 power, right? Totally you have 2 power 12 hosts. 2 power 12 hosts divided into 2 parts. Right? One half is given to A. Another half, again half is given to B. So one part is left out. One part is left out. With the given information, he is asking how many subnets are guaranteed. He is not asking all possible subnets. With the given information, how many hosts, how many subnets possible, because some maybe he is not using. Some maybe he is not using. Question number 23 over. Question number 24. Question number 24. The address of a class B host is to be splitted into subnets of 6-bit subnet number. Class B, 16 network, 16 host, splitted into subnet and host. Split into subnet and host. Split it into, right, subnet and host. Okay, fine. 6-bit, right, subnet number, and one more with 6-bit subnet number. And the 10. What is the maximum number of subnets and the maximum number of host possible? Maximum number of host possible is 2 power 10 minus 2. How much? 2 power 10 is 1024 minus 2, 1022. Remember, listen. Remember, sometimes he will subtract, right? Subnets are, listen, subnets are 6 bits. So 2 power 6 subnet, 64 required actually. 64 required. Sometimes he will subtract. Subnet also, all zeros, all ones he will subtract sometime. Sometimes you don't do. So as per the options you have to go. As per the options you have to go. In some problem, subnets, all zeros, all ones is eliminating. Sometimes he is not eliminating, but anyhow, host is the one who will decide, right? Don't worry. In some problems he is doing, some problems he is not doing. You no need to bother. Right? So that is not a criteria at all, right? Only one option will be there. You no need to bother. What is the maximum number of subnets and the maximum number of hosts in each subnet? 10 bits are there, 2 power 10 minus 2. Host is always minus 2. Subnets, right? Sometimes he is doing, sometimes he is not doing. No need to bother. Right? So don't worry anything about subnet. Subnet, don't worry. Subnet is 2 power 6. Listen, subnet is 2 power 6, 64. If 2 power 64 there, select 64. 64 there, select 64. 64 there, select 64. Right? Not there. Yeah, go to the next problem. See, from today onwards, if anyone asks you subnet, how many subnets possible with the 6 bits? 2 power 6. 2 power 6. Right? If really not there, if it's not possible, then select some other option. Someone is saying 64,010. What is that? Well, I will try once. See this one. I will try. What is the maximum number of subnets and the maximum number of hosts in each subnet? Are gootle. Each subnet. Each subnet. Right? It is not there, na? That is the reason. Fine. Go to the fine. 60. Someone is saying 64. See, this one you cannot. This one you cannot. Someone is saying that D option good, na? Host is always 1022. Host you cannot compromise. Because in these many hosts, 1024 hosts there, all zeros net ID, all ones DBA. All in the host part, all ones DBA. In the host part, all zeros net ID. It is always will decrease. But subnet sometimes will decrease, sometimes will not decrease. Because what purpose he is decreasing also, I don't know. Sometimes he will decrease, sometimes he don't decrease. But host is always will decrease because all zeros is net ID, all ones are going to be DBA. Right, fine, that's okay. Go to question number 25. Remember, go back by n, right? See this one. Stop and wait. Go back n. Select to repeat. This will follows individual ACK. This will follow individual and cumulative. This will follow only individual. Stop and wait, individual. Go back and individual, cumulative both. Select to repeat, individual. Yeah. That's 25 at the 26. Question number 26. Can you see this? Someone is saying check D option. What is the D option? 64 subnets, 1024, 1022. Hosts are always 1022. Hosts are always 1022. Subnets are 2 power 6. That's it. Because right? Because I said that time itself. If number of bits are 1 bit, right? It is having cumulative, but number of bits are sequence number purpose 1 bit only. So 2 sequence numbers possible. Two sequence numbers possible, 0 or 1. 0 or 1. So both, right? So sorry for this. C is the answer. I thought B is both. Yeah, C is the answer. Both A and B. Go back and ARQ. See this one. Go back and ARQ. Go back and ARQ. Answer is both. C is the answer. Maybe unknowingly I selected B. Right? Actually, right? Listen. Actually, go back by n is cumulative only. Actually, go back by n is cumulative only. But the problem is, right? But the problem is sometimes, right? Sometimes assume that sequence number is 1. What is the meaning of go back n? What is the meaning of go back n? Right? Suppose assume that you know I don't want to go inside that. Just remember this one, right? This one. If the number of sequence numbers are 1, in your nodes also it is covered. If the number of bits sequence number is 1, right, then it is going to be, right, it's behave like a stop and wait protocol. It behave like a stop and wait protocol. Go back by n, where sequence number contain only 1 bit, it will behave like a stop and wait. Yeah. Actually it is a cumulative, right? Sometimes it will behave like a stop and wait also. Because of, right, sequence number contain only 1 bit. Right? Fine. Go to the next one. Question number 24 over 25. Question number 25. In the diagram shown below, L1 is a Ethernet LAN and L2 is a token ring LAN. In IP packet originates from sender S and travels to R as shown. The link within each ISP and the corresponding two ISPs are all set to the point optimal links. The initial value of TTL is 32. The maximum possible value of TTL field when R receives the datagram is. Now, one small question I want to ask everyone. I want to ask one small question. TTL will be, listen, TTL will be decremented by, TTL is there in the network layer. TTL is there in the network layer. Network layer means router. TTL means network layer. TTL field is there in the network layer. Network layer means router. I think everyone know this is router. ISP means this is also router. This is also router. This is also router. This is also router. TTL means network layer. Network layer means router. But it is a LAN. It is a LAN. It is also a LAN. LAN and router no relation. So initially at this place 32. Remember at the source. Initially 32 will be kept. It became, right? So at this 32 place only, nothing will decrement. Here 31. Here 30. Here 29. Year 28, year 27. Remember, it came to receiver means at this place also, listen, it came to receiver means at this place also, it will decrement. Because without crossing network layer, you cannot go to receiver. Right? When packet is coming like this one, it is you. So here network layer, it has to cross, then it will go to application layer. So when it is going like this, it is going to be 27, It became 26, then it will go here. At the receiver, that's what I am saying. At the receiver got that packet means through network layer only got it. Receiver got that packet means through network layer only got it. Means network layer changed that 27 to 26. So conclusion of this one is, remember, conclusion of this one is TTL will change at routers. Remember, TTL will change at routers. Next one, TTL will assign at source but no modification. Next one, TTL will modify at receiver also. TTL will change at routers only. TTL will assign at source but no modification. Initial value kept at source. So it is in our problem 32. After all routers are over, it became 27. TTL will change at routers only. So it became 27. TTL will modify at receiver also 26. Yeah, can you see this problem? Consider the store and forward packets pitched network given below. Assume that the bandwidth of each link is 10 power 6 bytes per second. A user on host A sends a file of size 10 power 3 bytes to host B through routers R1 and R2 in 3 different ways. So I think from sender to receiver, packet will be sent in 3 different ways. One way is, in the first case, single packet containing complete file is transmitted from A to B. In the second case, the file is split into 10 equal parts and the packets are transmitted A to B. In the third one, file is split into 20 equal parts and these packets are sent from A to B. Each packet containing 100 bytes of header information along with the user data. Consider only transmission time and ignore processing, queuing and propagation delay. Also assume that there are no errors during transmission. Right? This is a problem. It's a nice problem. Please read one more time. I read many times. You read one time. In the previous problem, see in this problem, I given conclusions also. Initially at the sender, TTL will be 32. At every router it will change. So it became 27. TTL will change at the receiver also, because when the packet is going to through receiver, right? When the packet is going to receiver, at the receiver you have to see network layer. Network layer will change by 1. So it will become 26. Okay, that's okay. Come here. Yeah, so can you see this? See, the bandwidth of each link is 10 power 6 bytes per second. A user on host A sends a file of size 10 power 3 bytes to host B through router R1 R2 in three different ways. A user on host A sends a file of size 10 power 3 bytes to host B, right? Now see everyone, bandwidth of each link, see this link, bandwidth of each link 10 power 6 bytes per second. Now careful, very interesting, bandwidth is going to be 10 power 6 bytes per second. That means 10 power 6 bytes will take 1 second time. 1 byte will take how much time? 1 by 10 power 6 seconds. Yeah, now fine, I think, right. Now B, right? So 1 byte. So bandwidth is 10 power 6 bytes per second. Means 10 power 6 bytes will take 1 second. 1 byte is going to be 1 by 10 power 6 seconds. Okay, until now it's fine. Can you help me one small line? That is okay. I'm thinking that you are absolutely fine. Please give answer to me. Until now this is the time. How many bytes you want to transmit? You just say to me. How many bytes you want to transmit? 1 byte time is this much, I'm okay. 1 byte time is this much, I'm really happy. 1 byte time is this much, I'm really happy. How much thing you want to transmit? How much you want to transmit? A user on host A sends a file of size 10 power 3 bytes to host B through routers R1 R2. In the first case, a single packet containing the complete file is transmitted to B. In the second case, like that, it's okay. Now can you see the last line? Each packet contains 100 bytes of header information along with the user data. Consider only transmission times. Remember, consider only transmission time, ignore remaining. Only transmission time you take care. Ignore other things. Only transmission time you take care. Other things you ignore. So please help me. If you really okay with this, right? So you want to transmit 10 power 3 bytes. 10 power means 1000 bytes. 1000 bytes you want to transmit plus this 100 also, because in the first case single packet going, right? This 10,000, right? So almost like 1000 bytes packet is going at a time. 1000 bytes plus this 100 bytes, right? Now let me write now. 1000 bytes plus 100 bytes. Transmission time how much? So what is the answer? Right? It is going to be 1100 by 10 power 6 seconds. Yeah, can you calculate properly how much it is? 10 power 3 plus 100. These many bytes to transfer how much time? 1100 by 10 power 6. How much it is? This is one link. We are talking about one link. Yeah. If you want three links, calculate into 3. So if you want, you can do 3 into 1100 by 10 power 6. Yeah, please let me know what is the answer. Calculate properly. How much? 3.3 milliseconds. 3.3 milliseconds. Okay, this is first case. This is first case. Can you see the second case? Can you see the second case? What the second case is? In second case, the file is split into 10 equal parts. So 10 equal parts means 100, 100, 100, 100, 100. In second case, the file is split into 10 equal parts. 100, 100, 100, 100. So what is the answer? Please try. What is the answer? 100, 100, 100, 100, 100 like that. I think if you add the header also, it became 200. It became 200. So see the second one. Second case I am doing. Second case. So 10 parts. 1000 into 10 parts. It became 100. Plus one more 100 extra there. You have to add it. One more 100 is there extra. So it's totally 200 you have to send. So let me write now. 200 by 10 power 6 into 3 into 3, right? But remember everyone, right? Remember everyone. Do you know pipelining or not? I don't know. Listen, do you know in the first one because of one only, in the first one because of one packet only, right? In the first one because of one packet only, one packet coming from here to here. One packet is coming from here to here. How much? How much is there? Maybe 1.1 millisecond. It is coming here to here. One more 1.1 millisecond. Here to here. One more 1.1 milliseconds. In the first one. But in the second one, right? One packet is taking 200 by 10 power 6 into 3. That is okay. But whenever it is going, you can use pipelining. Because of so many packets are there, you can use pipelining. What is the meaning of pipelining is? What is the meaning of pipelining is? See this one. What is the meaning of pipelining is? Everyone know. See, what is the meaning of pipelining? When second one will go to here, in the same time you can keep first one here. When the third one will go to here, at the same time you can keep the first one, second one like this. So what I mean to say is just learn pipelining. In the pipelining, first one only will take more time, remaining all will take, right? Remaining all will take 200 by 10 power 6 only. There is no 3. How many? 9 people. First person will take 3 rounds. 200 by 10 power 6. 200 by 10 power 6 3 times. But the remaining 9 people will take 200 by 10 power 6 one time only. Yeah, can you calculate how much? Pipelining, using pipelining. So I written also using pipelining. Second one, when you say pipelining, let us assume that first person required 5 rounds, each of 10. First person required, right, 5 rounds, each of 10. Second person required 1 round only. I am repeating once again. First person required 5 rounds, each of 10. Second one required in the pipelining 1 round only of 10. Third one required 1 round only of 10. Fourth, right? So those people who don't know pipelining, I want to say to you one thing. Listen, pipelining. First one required 5 rounds, where each round is 10. Assume. Second one required in the pipelining, right? Without pipeline, what happened is, without pipeline, first one required 5 rounds of each 10, which is going to be 5 into 10. Second one also required 5 rounds of 10, so 5 into 10. Third one also required 5 rounds each of 10, so 5 into 10. This is called without pipelining. With pipelining, right? First person taken 5 rounds of 10, which is going to be 5 into 10, right? Second one Second one required 1 round of 10. 1 into 10. Third one 1 round of 10, which is going to be 1 into 10. So what I want to say is first one required 5 rounds, remaining 2 people required 2 rounds only. First person required 5 rounds, remaining people 2 people required 2 rounds only. That's what I'm saying. That is the meaning of pipelining. Pipelining is there in the COA also, everywhere in the total computer science that will come. Right? So when you have more packets, you can do. See this one. 1 round required 200 by 10 power 6 milliseconds or 10 power 6 seconds. But right, it is a 3 rounds. First one required 3 rounds. But here, right, everyone required 1 round, like that 9 people. Can you calculate it? Can you calculate it? Can you calculate? Just use pipelining. Just use pipelining. Lack of space, I am adjusting. Lack of space, I am adjusting. Lack of space, I am adjusting. Third one also I am doing. Can you see the third one? Can you see the third one? Third one is saying that how many parts I should do? Third one, 20 equal parts. 20 equal parts I should do. 20 equal parts. So can you help me now? 1020 equal parts. It is the third round. 20, 0, 0. I think 50. Plus, add 100 bytes extra. Total 150 by 10 power 6. How many times? How many rounds? 3 rounds. 150 by 10 power 6 into 3. This is for first person. 150 by 10 power 6 into 3. This is for first person. Remaining 19 people. 150 by 10 power 6 19 times. Calculate properly. How much? How much? Can you calculate? Here also pipelining. Here also pipelining. Can you say what is the second one? Second one. Someone is saying 2.4 milliseconds. This also 2.4 milliseconds. Someone is saying T3 is 3.3. So calculate properly. I am not done anything. Calculate properly. How much it is? T3 how much? Yeah, I am writing. Someone is saying 3.3 milliseconds. It is also milliseconds. It is also 2.4. So then T1 is equal to T3. See the option. T1 is equal to T3, where T3 is greater than T2. Then answer is D. Calculate properly. I have not done anything. Yeah, that option also there. T1 is equal to T3, which is greater than T2. This option also there. This is the answer. Do calculations properly. Use calculator and do it. Use calculator and do it. T1 is equal to T3, which is greater than T2, T2 less. Right? So use pipelining, using pipelining concept. Using pipelining concept. Yeah, so I think he's saying that, right? Let's read the problem once. Any clue given, let's check. In the first case, single packet containing the file is transmitted, and these packets are transmitted A to B. In the second case, like that, each packet containing, right, consider only transmission. Assume that, right, transmit which of the following. I think that is the reason it may be. I think something like aptitude. Something like, I think it is a combination of, right? It's a combination of COA and CN, both are used. It is a combination of COA, CN, right, digital, all are used. It is a combination of, right, all are used. It is a core computer science problem. Shreyas, it is a computer science problem, right? So because he is asking transmit the file second and third. Because of many packets are there, you can use pipelining. Because of many packets are there, you are using pipelining. Can you go to question number 28? The efficiency of any error detection scheme decreases. The efficiency of any error detection scheme decreases. Efficiency of the error detection technique decreases as the length of the data increases. A. The efficiency of any error detection scheme decreases as the length of the data increases. Remember this. The efficiency of any error detection scheme decreases as the length of the data increases. Length increases, efficiency will decrease. Right? Length is increases, efficiency will decrease. That is the reason we have framing. Framing means, right, if the bigger one, right, efficiency decreasing, let's go for a framing. Framing means making bigger packet into smaller packet. Go to the 29. So it is a number 1, it is a number 2, it is a number 3, it is a number 4, it is a number 5. Totally 5 people are there. 1, 2, 3, 4, 5. Can you help 1 to 2? How many people differ? How many bits differ? 1 to 2. How many bits differ? 4. 1 to 3. How many bits differ? 4. 4. 1 to 4. 1 to 4. How many bits differ? 4. 1 to 5. How many bits differ? 4. Next one. 2 to 3. How many bits differ? 2 to 3. How many bits differ? 4. Next one. 2 to 4. How many bits differ? 4. 4 to 5. How many bits differ? 4. Next 2 to 5. How many bits differ? 8. So find out all possibilities. Find out all. Among all, which is minimum? Find minimum. 4. This is called as Hamming distance. This is called Hamming distance. This is called Hamming distance. This is called Hamming distance. Among all the people find out minimum. That is called Hamming distance. 4 is the Hamming distance. See this one. If Hamming distance is 4 minus 1, 3. So maximum 3-bit errors detected. Maximum 3-bit errors detected. Error detected. If the if the Hamming distance is 4 minus 1, maximum 3-bit error detected. Maximum 3-bit means 2 also okay, 1 also okay. Next one. 4 minus 1 by 2. Maximum 4 minus 1 is 3. 3 by 2, 1.5. Take the floor value. Take the floor value. Take the floor value. So 1.5 floor value means 1. Maximum 1 bit. Maximum 1 bit error corrected. Maximum 1 bit error corrected. I will write the formula. If Hamming distance is d, maximum d minus 1 bit errors detected. Maximum d minus 1 bit errors detected. Maximum d minus 1 by 2 floor value bit errors corrected. So please remember, if Hamming distance is d, maximum d minus 1 bit errors detected, maximum d minus 1 by 2 bit errors corrected. Detection, correction is less. Detection more, correction less. Remember, out of all these people, Hamming distance more, one less is detected, by 2 is corrected. Yeah, fine. That is the question number 29. Go to the question number 30. Which of the following does not require acknowledgement by the receiver? Which one of the following does not require acknowledgement by the receiver? Remember, if the positive thing, right, if something is positive, I'm repeating once again, if something is positive, right, then send the acknowledgement. If something is negative, you no need to send acknowledgement. Let us know that something is negative. If something is negative, discard. If something is negative, discard. Positive, inform. Negative, you no need to say. Discard after some point of time. Right? Timer is over. You can resend back. After some point of time, timer is over. You can resend back. So what is the answer? Error correction or detection? Error correction or error detection? Which of the following, right, does not require acknowledgement by the receiver? Whenever error detection, packet will be discarded. After some time, timer is over. You can resend back again. See, positive things only how to inform. See, when you say error correction, packet is perfect. You can send ACK saying that send the next one. Right? Answer is A. If error is detected, packet is discarded. You no need to send ACK. After some point of time, timer is over. You will resend again. So remember, positive things only say, negative things don't say. Something positive say, successful say. Not successful don't say. Fine? Successful say, not successful don't say. Correction means successful. Not successful, just discard. If you discard some point of time, timer is over, you will resend again. Positive things say. Positive means packet received properly. Packet received properly, then inform. Packet received properly, then inform. Positive say, not positive don't say. In your life also, something good talk, bad don't talk. Something good talk, bad don't talk, leave it. Something bad, leave it. Something bad, leave it. Something good, then inform. Something good, inform. Right? So I think 30 problems are done. 30 problems done. Right? See you in the next class.